Hello students, in this video we are going to discuss 4.3 and 4.4 from laws of motion. Give the magnitude and direction of the net force acting on a stone of mass 0.1 kilogram just after it is dropped from the window of stationary train. Just after it is dropped from the window of train running at constant velocity of 36 km per hour, just after it is dropped from the window of the train accelerating with 1 meter per second square, lying on the floor of a train which is accelerating with 1 meter per second square, the stone being at rest relative to the train. Neglect a resistance throughout. Coming to the solution, here also we need to find out the magnitude and direction of the net force acting on the stone. Just after it is dropped from the window of stationary train. That means the stone is just acting as like freely falling body. If it is freely falling body, it will experience a force that is nothing but gravitational force. So, the net force acting on this one is equal to mg. 0.1 if you take g value is 10, that is nothing but 1 Newton. It acts vertically downwards. Coming to B, just after it is dropped from the window of train running at constant velocity of 36 km per hour. Here also the train is running horizontally with constant velocity. And here also it is mentioned that it is just after it is dropped. So, in this case also the net force acting on the stone will be mg, that is also 0.1 into 10, 1 Newton acting vertically downwards. Coming to C, just after it is dropped from the window of train accelerating with 1 meter per second square. Here be careful. Suppose if the stone is within the train, it can experience horizontal force also. But it is just after it is dropped from the window of the train. The train is accelerating with 1 meter per second square, but it is dropped from it. So, F net is equal to, suppose if it is within the train, if it is in the train, is equal to MA that is 0.1 into moving with an acceleration 1, that is 0.1 Newton along horizontal. But this case we should not, because it is dropped from the train. So we no need to discuss about this. So finally it is dropped. So what will happen? The net force, this one we don't want. F net is equal to mg, that is 0.1 into 10 is nothing but 1 Newton vertically downwards. So this is the answer for C. While coming to D, lying on the floor of a train which is accelerating with 1 meter per second square. The stone being at rest relative to the train. Now, here the body or the stone is not dropped. It is within the train itself. It is moving along with the train. It is moving with the acceleration of the train. So, definitely, it will have the force in the direction of motion of the train. So, acceleration of the stone will be is equal to acceleration of the train, that is nothing but 1 meter per second square. Therefore, net force is equal to MA, that is nothing but 0.1 into 1, that is equal to 0.1 Newton along horizontal. You may have one doubt. So, why the gravitational force is not acting here? The gravitational force is acting. The gravitational force is acting on this one. That is mg. At the same time, the same force, the same magnitude of the force is exerted by the contact surface, which is called as normal. So, vertically, F net is equal to 0. So, only we have the force along horizontal. Coming to 4.4. One end of the string of length L is connected to a particle of mass M and other to small peg on a smooth horizontal table. If the particle moves in a circle with a speed v, the net force on the particle directed toward the center is. Now here on a table there is a particle of mass M. It is attached with the help of the string and it is moving with certain velocity v in a circular path. Then what is the net force on the particle towards the center? Here our option is tension alone. So, answer is option 1, that is tensile force. The net force on the particle directed towards center. This is nothing but provides necessary centripetal force to the particle moving in a circle. Thank you.